Thank you for all being here. I really appreciate it. So just to kind of introduce myself, I work at Pinterest. I'm a product manager managing the cloud and the data infrastructure teams. Previous to Pinterest, I used to work at Twitter. I was leading product management there for the internal cloud platform, building the Twitter compute platform. Today, I will be talking about microservices lifecycle management, some of the learnings from working at these companies, on how to build and scale microservices up. And more specifically, with the advent of the public cloud, where it's almost everywhere available, the availability of the on-demand resources, it's kind of critical to kind of understand how you can leverage those resources with some set of governance. I think one of the biggest problems today is that it's a wild, wild west, right? There is no structure, there is no process around how you can leverage these resources. And using our experience working both on the data centers and the public cloud, I wanted to share some of the learnings on how we kind of try to tame that beast of managing microservices, having some governance around it without annoying any of the engineers with a lot of set of processes, right? So that is kind of the context of this whole talk. The agenda for today is I'll talk about some history about how microservices came to be at companies like Twitter and Pinterest, and then moving on to talk about specifically about the life cycle of a service or specifically of a job. I will describe what a job is as well in this context. Moving on, what is governance and the challenges around that when you're actually running the hundreds and thousands of microservices. And finally, the future and how we're actually trying to solve this problem, at least at Pinterest at this point. So, how many of you have actually used Pinterest? Any of you? OK, great. It's an amazing company. I recently joined Pinterest, and I've been surprised at how big they are, at least the scale of their systems. Pinterest is it's a curated list of ideas across the world. It's a collection of objects, items, images, videos, be it what, but curated by humans. I think as of last September, they have about 75 billion pins. Pins is their unit of resource, very similar to how tweets are for Twitter. And 75 billion is a pretty big number. And one of the key things or the key challenges is how do you discover these pins within this huge catalog? The way we see it is Pinterest is more of a visual discovery search engine, not similar to Google, where you can go and ask a question and get a very objective answer, but more about subjective answers. For example, how should I decorate my house? Or what is the recipe to cook certain things? Or how can I get a new car or color my car or things like that? Like what kind of accessories can I get for my car? So given such very subjective questions, how do you discover an answer? So it's a process of discovery, going through multiple pins, looking at curations, how people have curated ideas together, getting inspired, and trying to actually get it done as well. They recently launched a feature called Tried It, where you can actually look at an idea, and once you try it, you can actually let people know that you've tried it and give feedback on that as well. Anyways, back in 2010, that's when Pinterest was started, and it looks something like this. Very primitive, a monolithic Django application, which did pretty much one thing, just collect media across the web and categorize it across some catalog. Fast forward to 2017, Pinterest has come a long way since then. One of the new features the team recently launched, and unfortunately, since this is a PDF, I cannot show the video or the animation, is something like the lens feature, where you can actually take your app and click a picture of any real-world item. We will categorize it based on the information we have about that item running through some machine learning model. And we will let you know related items, which are very similar to that. It's a pretty cool experience, and a lot of companies are trying to solve that problem, especially Google. But then Pinterest has come one step ahead simply because of all this metadata input by users about what an item really is. In this example, if this GIF really played, you would see various categories of things, like it's a clock, it's a wooden clock, it's got Roman numerals, and those would be all the categories, and it will show a list of relevant clocks, which are very similar to those categories. And what it's worth, it's really not machines who have been categorizing this, but it's been people. So it's more relevant when you're searching for something. given in the direction where Pinterest is moving, we have seen some significant scale challenges which led to moving to the microservices world. So we still have the large monolithic Django application running at Pinterest, but at the same time, we have a lot of microservices around it supporting specific functions of the large monolith, specifically the core services which serve the pins or take in the writes for the pins or serve the boards and those specific primitives. But along with that, we also enable other engineers to build a lot of different services, supporting the ads function or discovery functions and things like that. To kind of give you a sense of scale, this is the number of microservices, while number of offline jobs, it goes in the tens and thousands, and the VM instances, again, it's pretty huge. Just kind of sidetracking from here and looking at how Twitter was. So previously, I used to work at Twitter, like I mentioned before. Twitter has a completely different set of challenges and problems to solve. It's a real-time messaging system, more specifically a broadcast mechanism rather than one-to-one. So there's a whole list of challenges around how you fan out messages to a certain list of users, how quickly can you do it, and such. Twitter early on moved from the monolith, which is the large Ruby on Rails, which we used to call aptly the monorail back in the day, to microservices after an incident at 2010. This was when the FIFA World Cup happened, and I think Spain won at that point. But for every goal scored, on literally every minute, Twitter would go down simply because it could never sustain that level of tweets per second. And that really prompted the company to rethink and how you enable reliability at that scale. And that prompted us to all think about how do you build microservices or move in that direction where individual systems take ownership of reliability, efficiency, and things like that. This is one of my to-go slides always to kind of explain the complexity of how Twitter was. These are like more than 2,000 microservices. What you're specifically seeing is the TFE or the Twitter front end, which usually takes in the request and fans that out to multiple services downstream. So that gives you a sense of how complicated or how big the Twitter microservices ecosystem is. All right, so TLDR. What have we learned? The obvious benefits of having microservices is, you have a clear sense of fencing and ownership. When you're working on the monolith, it's really hard. There are 100 or 200 plus APIs, and there would be specific owners to each of those APIs. You cannot really organize your team around those specific APIs, all trying to contribute code to the same repository or the same monolith. Then continuous integration testing, all of that becomes a mess, and the release engine or the release cycle itself is really hard to kind of orchestrate for what it's worth. So microservices does give you a sense of isolation and ownership and fencing by you owning individual systems and services. It also gives a sense of reliability because if one system goes down, it doesn't mean it has to take down like the entire site, right? You can gracefully degrade to a certain section of the services going down while still the other critical functions will still be running fine. The third thing is you can individually scale up services as well. In a monolith, you probably need X number of boxes regardless whether an API is serving that many users or not. But in the microservices world, you can definitely scale up and down certain set of services to the number of boxes they require, which obviously leads to some efficiency saving, not all, but some, which I'll be talking more about in detail. And finally, the developer productivity, right? It does make it simple for engineers to build and think about services, and you can really launch quickly without having a lot of dependencies between people and other services as well. This enables innovation at scale and helps move engineers fast. So microservices does enable organizations to scale. So these companies move from like hundreds of engineers, or even less than that, tens to hundreds of engineers to like thousands of engineers. The ability to kind of move from 5 to 6 teams to like tens and hundreds of teams. However, things are not always what they seem, right? If it was so simple, then we'd all be very happy and everything would be working fine. So it's really not what it seems, and that's really what I'm going to be talking about. So before I get into those specific challenges, let me just describe what is the life cycle of a job, of a service. I've been interchangeably using these words, but let me define what it actually is. At least in the world of Pinterest engineering, a job can be one of these things. It's a long-running service. It could be a bad job, which is doing certain map reduce or model training problems. It runs within a certain set of time, and it dies, and it keeps doing that again and again, like a cron job. It could also mean an experiment. Not many people think of experiments as a job, but now as companies have invested significantly in experimentation frameworks, machine learning frameworks, it's kind of critical to identify that as another entity as well. You have to think about how do you scale. Like, for example, experiments have like a finite set of time, but they run like long-running services. They don't serve all 100% of the traffic, but probably some percentage of the traffic, collecting data and pushing that to some offline data processing system. So you have to really think about that as another entity as well. So I am kind of going to be I'm going to be using job going forward now, but it could mean any of these. Regardless, the problems around the management is still the same. The governance problems are still the same. This is really primitive, but in really like a concise 30,000-foot view is like you create a job. There are certain steps you take to create a job. And then there is the release phase, the monitoring phase, and the deprecation phase. The deprecation phase is something we usually never talk about, right? Like, how many of you have actually deprecated services? I don't think a lot of people would have done that. So the process around deprecation is like black magic, essentially. You really don't know what to do, where to go and remove the code, or should anyone be even doing that? So not many people talk about it, but I think it's important. Kind of expanding on the central portion of things is, what does the release phase look like, and what does the monitoring phase look like? And I believe, this is my personal opinion, is that as a community, we have spent a lot of time defining structure and governance around these particular areas, the release and the monitoring phase, right? There are CNCF projects, tackling certain sections of these, and I feel like it's in a good shape. Like, you really know what you need to do when you're doing continuous integration or testing and things like that. You really know like what kind of stack you have to set up to kind of build a complete monitoring stack. But the unknown portions are really like the create and the deprecate phase, and which I think like has another portion on top of it called the management phase, or more like operations or governance. Again, I'm interchangeably using these words because each of them mean different, but I'll kind of like bring all of that together towards the end. So what does the manage phase actually look like? So, even when you're creating a service, you have to do some magic. You have to set up credentials. You have to set up a repository, probably add some kind of owner's file telling that you're the person who wrote that code. You have to go through, AWS IAM or Google Cloud IAM or whatever that is to kind of set up the relevant service accounts and things like that. You have to define some metadata in some config YAML files or JSON files. And that metadata could be as simple as telling that, hey, if there's something wrong with the service, this is the Slack channel you have to hit up, or primitive information such as that, dashboard links, alert links. The other one is the biggest one, which is like planning capacity. Just out of curiosity, how many of you actually plan capacity for your services? How many of you think about that? Okay, so it's a huge problem. It's one of the largest problems which many people fail to really think about, and we feel like orchestration systems will kind of help manage that to a large degree, but it's not true. In every company, whenever you're launching any service or job, you really have to think through how many resources you need right now, 3 months down the line, 6 months down the line, because what happens is once you start, you really don't think about it, and then you either have an incident because you now have more traffic to serve, or all of a sudden you're chugging in more data than you should be for your offline data job. And then again, it's an incident, and you have to, basically you just go back and write a postmortem saying, I didn't plan, sorry. And the final part is the budgeting and the spend portion as well. I'm sure many of you have been asked by engineering managers or leaders within your company as to how much does your service cost, or how much does the job cost, like how many resources are you using? And that's a hard thing to answer, right? Like the public cloud, they really don't provide you information at a service or a job level. They give you how many instances you used, how many S3 prefixes you have, or things like that. But how do you tie all that together to the concept of a job or a service? So that, according to me, is really the large problem to solve. And this is what I'm going to be talking about now for the next 10 to 15 minutes. So I think, in short, again, this is an amazing GIF, which I saw by the practical dev. It's the chaos, essentially, when you have like hundreds of thousands of microservices running in your company, where it becomes really hard to kind of figure out what is happening where. I will share this link. It's worthwhile to go and watch. All right. So we discovered early on, like, governance is needed. back at Twitter, when we had like over 1,000 plus microservices, it used to be like a constant thing for the compute teams to figure out like who are the top customers, like how much resources are they using? Because we used to run multi-tenant systems. Like our compute platforms were all multi-tenant. It ran on Apache Aurora and Mesos. Back when I was there, at least, we used to run more than 200,000 containers. The biggest challenge over there is like since it's a multi-tenant system, we were responsible kind of to scale our clusters out. And we have to figure out how our customers are going to scale in within the clusters. And again, Twitter ran on data centers. It was not the public cloud, so you really cannot go and acquire 10,000 more instances. So we had to pre-plan buying machines and things like that. So it was really crucial to kind of understand who are your top customers, how much resources are they using. So that's how this whole thing triggered off. Like, because we have so many services, we wanted to understand, like, OK, what do we need to do to kind of solve that problem? And that's when we realized governance is needed. Because we were also answerable to our leaders to say why the Apache Aurora Mesos cluster grew by 50x. And you cannot just point your hands to, say, a certain team and say, hey, they asked for like 10,000 cores or something. But it's a mutual thing. And you need to like make sure the accountability is at the right place through some sort of visibility. So before I get into those things, I'm just going to have like this simple service. This is not a real service at Pinterest, but I just want to talk about how these things look, right? Like you have let's imagine that if you're writing a pin write service, it's a deploy package, and it requires certain resources on the compute cluster itself. First thing you would do is definitely define some names, right? You have to define the namespace. You have to define some cluster names to say, this is who I am, right? And that needs to happen, again, through some config files, or you go to some self-serve UI to do that, or you literally like email someone or ping someone and tell that, hey, set this up for me. You have to set up your service discovery paths. You need to define a name again over there. And then you obviously require storage, blob storage, or some key value store. Now you have to go to those individual services and, again, define instances for your application. I'm sure everyone has done that, and everyone has given different names in each of these different steps all the time. And what happens then is the operators of these individual systems have a hard time figuring out who actually owns this particular instance of a, like a prefix in the blob store or a namespace in the key value store. How do you tie that back to this package, which is actually the pin write service? And that's a common problem across. And we saw that at scale. And it becomes really big when you actually have multi-tenant systems running at your company. So the first question was always literally who owns what? Like who is the owner for prefix X or key value store Y? And this was again a GIF. Everybody gets a spreadsheet, right? Like each of these teams, I remember, like used to have these large spreadsheets having all these different identifiers mapped to some person's name. And for what it's worth, like companies as large as Twitter or Pinterest, people leave, people come in, reorgs happen, many things happen, and it's really hard. Like you cannot expect a storage team or a compute team to kind of manage their spreadsheets on a daily basis. The whole point of multi-tenant systems is to like help people move fast. So you come in, you launch something, and you know that person's using X resources, and you charge them and all that stuff. So I've seen like many EMs in our teams like literally managing these spreadsheets on a daily basis. They track like resources asked by this user. They either link to a ticket or some email. But it's a pain. Like you don't want to be spending your time actually managing these spreadsheets. So that was one of the first problems we set out to solve. And at Pinterest, like one of the things we started doing is like thinking about, okay, what does that entity model look like? How do you solve this problem if you were to like automate this into a system, right? And it's an ownership directory essentially. So how do you define ownership, and how do you tie that back to a notion of a service, a job? And that's what this entity model describes. Ownership could be, it starts at a business owner level. You have your ads organizations. And I think I do have an example. Yes. So it kind of maps well, at least in the two organizations. I've tried to like build this out. It maps well to the larger business organization, the individual teams, and the projects they own. And it ties well to a notion of an identifier, an identity. In my example of the service which we were trying to build, the pin writer service was the service identifier, a canonical name which we want to define, which is something I think I'll talk next is how do you provision those identifiers per resource for a job. Like I said, we usually put in different names for our same service as and when we're requiring acquiring different resources. If you're launching VM instances, you probably have some different key value stored to describe ownership. While when you're launching your RDS or a storage cluster, you probably have some different names defined over there. So how do you tie those together? How do you kind of categorize or build an inventory of resources you want to provide to your engineers within the company? How do you build that and tie that to a notion of an identifier? Because at the end of the day, you don't want engineers to be writing these names regardless. Let's be honest, like naming is really hard. So that's one of the hardest problems in CS, at least I believe. So you don't want any of these folks to be writing those names. So how do you kind of automate that, or how do you figure out like a way to solve that? So that was the next step, right? So this is the same service I talked about. Like, so pulling those things out, like, so there's always going to be some canonical name defining all these resources to a particular job, regardless. If it's a Hadoop job, it's going to be some prefixes from some store you're going to pull, you're going to do MapReduce, and you're going to be pushing it out to some other data store or consume it through a service. Or if it's like just general compute, like, or even if it's in Kubernetes, you are going to define some canonical name, and you're going to have an identifier for that individual system. I think that's the first thing we identified. Like, we ended up building we ended up building an identity service back at Twitter, which had specific APIs which each of these infrastructure services would just talk to. What it essentially meant is we centralized the provisioning process. So engineers literally go into a console to provision the resources they need for either Hadoop or compute or storage or whatever that is. And they never go to these individual systems to go and provision something. So that way, we control how we want to start naming things downstream, and there's just a single name at the top. And that way, we just solve that problem, and we also take away the spreadsheets which each of these operators will be owning. If the operator needs any information, they can just look back into the identity service to figure out, who owns a certain UUID of my key value store. So that's one of the first things, right? Like, so who owns what? Then how do you identify? How do you create an identifier? How provision an identifier through an identity manager? The next step was, like, we realized that, okay, you have an identifier now, but many a times there's access controls associated to these identifiers. In storage especially, you want to make sure that the right services are using a certain namespace of a key value store or a prefix in S3. And you want to make sure those that's audited, that's logged, because again, those are all processes almost every company has to go through. So how do you manage credentials? How do you set up secrets? So again, this was another problem we had to solve. Like, at that point, you have a central credential provisioning service as well, where it talks to the identity service to figure out what the identifier is, and it also talks to the IAM systems of your public cloud providers to now merge all that together. So foo service, like, you can literally go into the console and see what are the credentials or what is the access control given to a certain identifier for your service. That way, individual operators, even downstream, don't have to worry about it, and they can just leverage the information from the credential provisioning service. And for what it's worth, at least at Twitter, we were building it into the RPC layer itself. So as your service comes up and it starts to communicate with any of these downstream systems, based on the identifier, the downstream systems can block your request and things like that. So we could enable service authentication and service authorization. Obviously, you need a management console to kind of define roles and what kind of access control for a certain resource to an identifier. So all that needs to happen, or at least it's happening as part of the credential manager. Now, the next thing we had a problem with was, like, where to look up job metadata and configuration. Again, these exist mostly either in the source code in some YAML files and JSON files, or sometimes in some MySQL database within operators. Like, so the use cases we had were, like, our SRE, or at least the reliability engineering team, would like to know across the fleet, like all the services really, where can I find, if there's anything wrong with a service, what is the dashboard I need to go and look at? What is the alert I need to go and see? Who should I ping? Or which Slack channel or which HipChat channel should I go and talk to? Or, like, what's the email of that team? And that was, like, usual operational metadata you want, like, at least the ownership side of things. At the same time, like, links to the dashboards and alerts. So where do you store all that information? Like, how do you tie that to the notion of a job? So at Pinterest, we use a system called Teletron. So we, well, more importantly, like, we deploy using our inbuilt deployment orchestrator called Teletron. It's an open source project. It looks a bit complicated right now. It's changed over time. But at Pinterest, we do VM-based deployments. We are in the process of containerization, and that's another story, and hopefully I can make a talk on that. But right now, it's still VM-based deployments, and one of the things is this tool actually has a host of buttons on the left, configure, where you have to like specify over 70 fields on what kind of metadata is there for each service. Now, that's painful. But again, that's modeled based on how the system works, and it's all required. It includes auto-scaling groups. It includes all that information which is required. But the thing is, it is not tied to a notion of the canonical identifier. Again, I can go literally launch something over here with some random name, and I have to do the same thing. But then I cannot, like, say, inherit or borrow from the actual service where I want those configurations to come from. So you want to start tying metadata of a service to the canonical identifiers. And that's another problem to solve. And we set out to solve it by building a metadata manager, the single source of truth for all job metadata. And this is basically going to be tied back to that initial entity model, which I showed you guys about ownership and identity. The idea is, like, you can always have a key value at the job level, but then it's a hierarchical model, so you would defer. If there's nothing specified over here, you just defer back to what's defined on the project side of things. You don't have to have multiple metadata at almost every job level, but this works at least pretty well for the use cases we had. And this is the part, I think, which is kind of this, and there's another one behind this. Like, I think these are, like, very important as well. Like, whatever I explained right now were all primitives to kind of help do this. How do you allocate infra resources consistently across your company? If you are, like, part of the cloud teams for your own organization, I'm sure you've thought through this problem. One of the things is, like, as part of governance, you don't want to open the gates to everyone. You don't want to, like, provide the AWS console access to every engineer in the company, or the GCP console access. You don't want to have some gates around it. You don't want to define a set of instance types you would like to allow. You want to define a set of primitive services, or even high-level services like Lambda, whatever that is, which engineers can use. It's not to restrict, but it's all about, like, providing some constraints, so it's ease of management at the infrastructure and the operations level, and also reduces a lot of cognitive overhead for the engineers to choose and decide when you limit options. If there's really truly a requirement, we can always have a conversation separately and onboard that as a resource to offer to the entire company. So one of the things we had to do, at least at Pinterest, we're doing right now is we're defining those resources. Again, like I said, it was a VM-based, mostly VM-based. Like, everyone gets access to instances pretty directly. We do have a concise set of instance types we allow. But then again, we want to start thinking, like, for the future. Like, if we were to move to the containerized world, how would that look like? You know, we don't want people to think in terms of instances going forward. We want them to think in terms of CPU, memory, and gigs, at least for their compute jobs. Probably something different for their batch jobs, because over there, it's more about how much memory can you crunch over a certain millisecond of time. At least in Hadoop, those are the metrics we care about. So we want to define those are the resource types for these infrastructure services we want to offer to our engineers, abstract the whole resource provisioning process through this resource manager, and then ask users to literally go to that resource manager and request resources. So the infrastructure teams, and now at least the operators, like the compute teams or the storage teams, now they're responsible to kind of have those multi-tenant systems available for their customers, and they control, like, what kind of resources they offer. So it's basically the inventorying and the provisioning of resources, and this needs to tie very closely with the identity system, because at one point, like I said, one of the initial problems is, given a prefix in S3, who owns it? And given a prefix in S3, how much does it cost? You really want it at that level, or even, like, if you were to think from a Hadoop perspective, given a job or multiple jobs belonging to a workflow, what are the resources it touches? It could be in S3, it could be in key value or MySQL. Where does it touch? What are the resources it touches, and where does it store something? So you want that dependency graph as well. So you have to tie whatever resources you're defining over here to that identity model to kind of build those kind of graphs. So yeah, like I said, we are building this centralized resource provisioning system, which will do the cloud provisioning for us. We don't let users themselves do this, but we are that intermediate service which will actually provision those resources on the cloud for them. And that way we can now have behind the scenes, either we still keep running on VMs or change it to Kubernetes or Mesos or whatever that is, and the user need not know at all. Users are still thinking in terms of CPUs and memories for their jobs, but we serve as that abstraction layer for them. And it makes it easier for the larger multi-cloud stories and things like that as well. And finally, I think this is one of the most important things we noticed at these large companies is that, at least I noticed, is how much are you utilizing? You ask for 100 instances, but how much are you really utilizing? How much does it cost the company? And this was one of the hard problems to solve because there's no clear way of doing this. Like I've heard multiple solutions about this. Like if you're on the public cloud, you could probably have different accounts, like mapped to teams, and they can do whatever they want, and you have budgets around that. But in a true, like as we're moving to this whole multi-tenant world, and you don't want to like put that burden onto your engineer, the user. You want to think in terms of the user being a customer to your internal cloud platform. So you have to provide all these abstractions or features to the user because all they care about is running a job, and they need to know how much it costs or how well they're utilizing the resources. So what we ended up doing, so back at Twitter, we ended up building a chargeback system where we could meter utilization of every job running across our compute systems, our storage systems, and Hadoop and other infrastructure services like messaging as well. And what we would do is as we meter utilization, we would also like figure out what to charge the user based on that. Now things get a bit different when you're running from the DC world in the public cloud world. So in Pinterest, one of the things we're seeing is that AWS already sends us a bill, and how do you figure, or how do you map that to the notion of resources and jobs, which I've been talking about? So you can give the right information to the engineering teams, tell them that this is exactly what you're using, this is how much you're costing, and you can actually do XYZ changes to kind of reduce that cost or improve utilization. Like I said, many a times what happens is, since there's no clear capacity planning process, and this comes back to governance as well, people often oversubscribe what they need. Like they would always ask for 1,000 plus more instances than they would require, and probably not end up using it for the next 3 months till they actually go and deploy the service for the first time. Till then, you will probably be paying that money for those 1,000 instances regardless. So you want to like catch all these things early on. The biggest pain point people have expressed is that it takes a long time to provision those things, or you just don't want to think about it right now. So you just get whatever you can right now and think about it later. So one of the things is like this enables visibility and accountability, and we define like some canonical schemas on how we want to meter this. We in fact leverage our internal observability and visibility systems to kind of meter utilization and subsequently like tell users that, hey, you asked for 100 instances, but you're actually using only X CPUs from these instances, and this cost the company so much, or in wastage. Can you do something about that? And this is key. Like at least at Twitter, we saw some significant gains on our compute infrastructure when we kind of started publishing such numbers. For example, this was one of the builds, like how it used to go out at Twitter. So this was to the tweet service team where we would send out, hey, you're using Aurora, and this is how many instances you're using part of Aurora, and here's the amount. You're actually costing so much. What this doesn't include, and actually there are detailed reports behind this, is how much are you actually utilizing from those resources? Manhattan was the key value data store at Twitter. So this was all allocation, what the users requested. There's also a usage component, which usually doesn't show up here, but in detailed reports. So I think I spoke about like the need for governance across these different areas, and I spoke about multiple individual services on how we're kind of tackling these problems, but they all come together, right? They all come together into like an internal cloud platform which you want to provide to your users, so they can like essentially not worry about managing the infrastructure or dealing with it directly, but rather through this. It also eases the life for operators, infrastructure operators, be it the compute platform or storage or messaging or whatever that is, in terms of not manually managing tenants, not manually managing resource allocations, but hooking up to the central system so all of that is managed for free. So one of the things which we were building is like together is kind of this intricate governance system where you could onboard different infrastructure and platform services into the system, and you'd expose that out to your engineers within the company through a single pane of glass, a dashboard. And this will essentially also manage the workflows around the creation of a new job, the allocation of resources to a new job, setting up credentials for the job, be it new job or existing job. It also helps with the capacity planning to show what your historical utilization of the job has been and what is the projected utilization. And finally, and most importantly, like telling you how much you're costing for that particular job. Because that is the most actionable item engineers can get, is telling what their job or their service is costing or in terms of utilization. So this is kind of how we're going about it and building. On that, thank you for being patient and listening. If you